be talking about Google's Dremel and BigQuery technology. So what is Dremel? Dremel is a general purpose system and service for running interactive SQL queries on multi-terabytes of data sets. It got its name based on a woodworking tool that uses speed instead of torque to get the job done. So Dremel is extremely fast. It's based on tree architecture. It uses a multi-level serving tree to execute queries. A combination of this multi-level execution trees and the columnar data layout, which is the column IO database or the column IO files behind it, using that it's capable of running aggregation queries over trillion rows tables in seconds. The system scales to thousands of CPUs and petabytes of data. Use cases of Dremel or the column IO analysis. Internally at Google, there are various use cases of Dremel. Google uses it to track installation data to do analysis on installation data track for Android market, for crash reporting for Google products. All of these Google products, Google Books, Google Maps, all of these generate a lot of log and usage data, that's data from users, and Google uses this Dremel technology in order to data mine all of these log and do analysis on it. So these are some of the examples of how Google is internally using Dremel. So what is BigQuery now? BigQuery is basically an external version of Dremel. BigQuery is the name given to the externalized version that's open to the public. So BigQuery allows you to run SQL queries just like Dremel. It's on large data sets. The data sets can either be your own or it can be shared either from public data sets or other storage devices like Google Storage, etc. BigQuery works best for interactive analysis of very large data sets, typically using a small number of very large append-only tables. If you're really interested in like relational database scenarios, you may want to consider Google Cloud SQL instead of BigQuery. BigQuery is really for big data. Google's Cloud SQL is another version of, basically it's MySQL in the cloud. So if you really have relational database usage or scenarios, you could consider Google Cloud instead of BigQuery. There are three ways you can access BigQuery, either through the browser tool or the command line tool, or by making calls to the REST API using various client libraries that are available in multiple languages like Java, Python, etc. Today I will be demoing each of these three things. I will be demoing how to use BigQuery on the browser tool, how to use it on the command line, and also how to do a REST API connection using Python. Briefly to summarize again, the difference between BigQuery and Cloud SQL. Like I said before, BigQuery is ideal for running queries over vast amounts of data. It's good for analyzing big data. It's more OLAP based system, whereas Google Cloud SQL will, if you're looking for something OLTP system, you can consider Google Cloud. The BigQuery isn't a database system. It doesn't support table indexes or other database management features. BigQuery supports a specialized subset of SQL. It doesn't support update or delete. It's basically an append architecture. BigQuery can be used by any client to send REST APIs over the internet. Large-scale data analysis. So large-scale data analysis is the blood life of many companies, especially nowadays. Big data is the hot technology. So parallel database systems were not quite designed for this extreme scales, and therefore there is this need of something much faster than the parallel database systems. And the other option we have is MapReduce. MapReduce is good, but it's not designed again for the use case. It's not easy to query using MapReduce. So it's not really easy to do data analysis using MapReduce. So cannot be used to execute queries. And then on top of MapReduce, we have Hive and Pig. Okay, data management. So Google has is using Google file systems or the distributed file systems. Google uses Bigtable. Google uses MapReduce, and there's also Flume Java nowadays used as the Java library for data parallel pipelines. Um, the backend of the main concept behind Dremel is being able to analyze data based on column IO. So what is column IO? The difference between record wise and column representation is when a query is sent to the query engine, it doesn't, if you need only certain columns, it's only going to look at those columns rather than looking at the list of all the columns in the for the record. So hence it's faster in terms of execution, in a nutshell. Then query processing, the data model is protobufs based. It's a select, project, and aggregate, single scan, read-only kind of architecture. You can do approximations. It's more accurate. It's in terms of using big data, it's more always useful to do approximations. Joins are limited. In terms of, I have realized that you can only join 2 tables at a time. And I will continue to demo a quick, give you a quick demo of how to use BigQuery. So as you can see over here, I am on the command line. Basically what I have done so far is I have, this is a command line interface for BigQuery. You can execute commands over here. If you want to execute a query, you can execute a query by stating the word query. ls is used to list all the data sets I have. And then if I want to do a query, I can do a simple query such as this one with the keyword query, and then in double quotes passing the query. So this should return the data. What I'm doing here is I'm fetching the data from public data sets that's available. I'm getting the average mother's years and average father's years age for every year in every state. So this is the command line interface. Quickly, I want to show you the source code, how to do this using REST API basically. So this is the code for using REST API. I do have, the only thing you need to do here is put in the client ID and the secret here. Each person has to generate that. I will quickly show you how to do the auth authentication, in order to be able to use the API. The destination for this is an export program which is going to query BigQuery and write out data to Google storage, very similar to what we've learned or we've heard before about Amazon's S3 bucket. So this is the Google storage services. So in order to run this program, I would do python export.py. This should run. When this program runs, it's going to give me a URL. It's going to, technically, if it's your first time, it's going to give you a URL, and you need to take the URL, put it in the web browser, get a token, and then type the token in here, and then it's going to execute the query. It takes a few minutes to do this, but basically at the end of this execution, you should have your you should have the data that you need. There are a couple of links that are easy to access. There is this Google Code API link, API console, which which is where you go to enable BigQuery. So if you are a first-time user, you have to create a project, and on that project you have to give API access and also give enable BigQuery. Basically, in the services, you need to go to Google Cloud Platform and enable BigQuery API and Google Cloud Storage if you are interested in that. Once you enable these, you will also have to enter billing information, because without that, it will not let you proceed. This is the web UI, bigquery.cloud.google.com. It's a very simple UI. You can execute. I have executed a few queries before, and I can run those queries again if I want to, or you can compose your own queries. And on the left hand side, you'll see all your data sets that are available. These are this data set I actually imported in my report. I do show you how to import more data sets. Thank you for watching. I hope you found this